Hi everyone. Thank you for joining, even though there was the problem with the link. So we'll just start directly with the presentations. But yeah, before that, some things you should know. The projects will start hopefully by the end of next week. We will float a form after this presentation where you can fill in your project references. So I think we'll allow around 10. And yeah, we will allot the projects to you within the next week. So you can start the projects after that. Right. So we can start with the presentations now. The first presentation will be for the project Machine Learning Behind the Curtain. So Hitesh, Arnav, and Sanjeev.
Yeah, so I'm sharing my screen. Is it? Okay. Yeah. So can someone confirm? Is it visible?
Yes, it is visible.
Okay, thank you. So yeah, hello everyone. Our project's name is Machine Learning Behind the Curtain. So first of all, what is machine learning and why do we want to learn it? So machine learning, going by the definition, machine learning is a subdomain or a branch of artificial intelligence which enables the machines to learn the patterns intrinsic in the data and later on apply it in real life applications. So what is it? What is our goal? So it minimizes human intervention. So basically, we want to automate most of the tasks that we perform ourselves in our day-to-day lives. Okay. So let me give you some examples. Like first of all, the movie recommendation systems that we see in Amazon Prime or Netflix or whatever we use is an example of machine learning application. So another example is the face recognition system, the face verification systems used in security systems. So these are some applications of machine learning. Another most recent example which was also in the news, and you might have heard of that, is that the COVID wave prediction models, like it predicted to very much great accuracy the timeline and duration of the COVID waves. So sounds interesting, isn't it? So coming to the project, since Stamatics is mainly concerned with mathematical aspects of things, and the project name also suggests that we are looking behind the curtain or under the hood. So we will mainly be concerned with the mathematical aspects or mathematical foundations, theories, and concepts of the algorithms that we implement using the programming languages. So let me build the motivation behind this. Why are we using the mathematics? Why are we seeing the behind the curtain? Why not simply implement it? So let's say you learn all of these algorithms, you know how to implement it, but in the future, you want to customize one of those algorithms for your own task, or you want to say build a new algorithm for your research work or do similar things. So for these things, you can't do this unless you know the foundations on which these algorithms have been built. So that's the motivation why we are going to study these mathematical aspects. So of course, we will be implementing these, but we will not use those specialized libraries like scikit-learn or Keras or whatever. So we will be using Python and basic NumPy most of the time for implementing the assignments. So yes, that's what has been decided as of now. Coming to the components of the project, we will be starting with basic linear algebra. Then we will introduce you with the basic algorithms such as regression, classification, clustering. Then we will introduce you to neural networks, simple convolutional neural networks, the recurrent neural networks, and then some applications such as neural style transfer. Then we will also tell you about the various loss functions and optimization algorithms, both standard ones and the customized ones. So might sound overwhelming at this time, but we will see this step by step. So lastly, the logistics. This project will take around 8 weeks or 2 months, we can say. The expected time is 5 to 6 hours per week, but of course, that's subject to change as far as the topics are concerned in that specific week. So initially, we had decided to prefer the project for Y21, but for other batches too, if they are interested in the topics mentioned above, then they can go for our project. Lastly, the prereqs. So the prerequisites, first of all, basic linear algebra is a must. up to the JE level. That's at least you must be familiar with. So like the operations on matrices, multiplications, the dimensions of matrices after performing these operations, etc. And so MTH 102 will also help you for Y21 also, like they will be doing this course. So yeah, that's good for most of us. But another thing is like we would recommend some basic Pythons for implementing those algorithms in the assignments that we provide. So by basic Python, we means familiarity with like the familiarity with functions, arrays, importing libraries, etc. Some basic things in Python. So that would be very good for as we move with this project. So yeah, that's all from our side. Thank you so much. And if you still have any queries or doubts, feel free to contact us. These are our Discord usernames. So I hope it helps. Thank you and have a nice day.
Okay, so next we have Fahad, whose project is on quantum algorithms. Okay, I think Fahad is not here actually. Can Shreya Bhattacharya and Pranshu Gaur present mathematical tools for data science?
Yeah, okay. Just wait a minute. Yeah, so is my screen visible?
Yes, it is.
Yeah, so basically our project is mathematical tools and algorithms for data science. And first of all, the overview of this project. So this project will introduce you to the basics of mathematics behind one of the most popular field of study, that is data science. And we intend to cover various topics such as probability, statistical knowledge, and it will include many topics that you currently Y21s might be knowing, that is from MSO 201, that types of probability, statistics like descriptive statistics, inferential statistics. We'll also cover a part of linear algebra, and then we'll move on to the implementation part, that is Python programming. And then if you are not familiar with Python, then it's no problem is there, because we'll be sharing resources. And then we'll move on to some of the Python libraries that are relevant for data science. And we intend to cover some algorithms as well if time permits. And finally, all of these will be implemented through a project. And for the regular evaluation, there will be assignments and quizzes, and also one normal basic coding course will be there to make you familiarized with the Python programming language. So what is the objective of this project? So basically, you will understand what is data science, and why data science is so important, how is it changing the world, what are the boundaries between data science, machine learning, artificial intelligence. And for example, you might be knowing that data science is a multidisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. And you might be knowing, or we'll tell you, that data science is extensively used in business decision scenarios nowadays. So companies are using data science to build recommendation engines, predicting user behaviors, and many more things. Whereas artificial intelligence is basically the ability to impart to computers, which enables these machines to understand data, learn from it, and make decisions. Whereas machine learning helps us in the implementation part. So it makes the data understanding to implement it, and it basically is a subset of artificial intelligence and data science. So you will get to know much about it in during the project. And so the main objective of this project is learning, and learning. So this is a roadmap about our project. So first of all, you'll be accustomed with the data science information. What is what is it, what are the types, and everything regarding to it. And then we'll move on to the categories, types of data, and what are the terminologies related to mathematical tools behind it, like probability, statistics, and how do we sample data, what are the different techniques regarding. And then we'll give various statistics and probability theory, and then we'll move on to the implementation part. And this will happen in week 5 or 6. And in between them, you will get a coding contest to get you familiarized with the Python programming language. And then we'll move on to the libraries. And in the end part, we'll teach you some algorithms like regression, decision tree, random forest, naive Bayes. And using all of this, you will do a project, and then we'll end it. So this is what we expect from all the mentees, that 2 months is the duration and 6 to 8 hours commitment. This commitment is flexible, like it depends on your understanding as well, and as well as the topics that the week has. And then this is the timeline. So you will be shared this PPT, so you can look at it later. And finally, the prerequisites, there are none. So basically, if you don't know anything, then also you can join us. And if you know some basic things, then it's great as well. So, but one thing is for sure, freeloaders will not be entertained. That means if you're joining this project, you have to be serious during both the 2 months. So these are the mentors. You can contact us on Discord if you have any doubt and any questions if anybody has.
How to join the project and when do we get the link or anything?
After this meeting, I think you'll be getting a Google form. You have to fill your priorities, and then you'll be able to join us.
So we don't need to know anything about Python for this course?
You can start reading about it, and if you don't know, then also it's well. We'll be sharing resources, and you can learn from it.
Okay.
Hello. Will these courses be conducted online or in the campus?
No, right now we have decided to conduct it online, and later on we'll ask all the mentees and decide it. Right now, the more decided is online.
I just have a general doubt. Can we do more than one of these projects?
I think no. That depends. You have to ask the coordinators regarding that.
Okay.
Is there a maximum size for one course?
I
We will
don't
look
have
at that
idea.
during project allotments. So yeah, we'll take into consideration how many people are applying and things like that. Was the previous question about whether you can take more than one project?
Yeah.
Yeah, so officially you cannot take more than one project. If there are fewer participants than we anticipated, then we would let you, but yeah, for now, assume that you are only going to get one project.
Okay, sure.
No, like I didn't understand the question, I mean, properly. Like if I'm
How
taking
will the-
one from mathematics department, then I mean, from Stamatics, then can I go and take another one from consulting if they're giving one? Hello?
Sorry, could you repeat that, please?
How will the courses be allotted? Do we have to submit a choice list,
Yes,
preference
you
list?
will have to submit a preference list. We will float a form right after this meeting, and we will explain how the process will work then.
Okay.
Yeah, hi. My question was that in case I'm taking this project with Stamatics, can I also take another one from consulting or some other place? Like,
Yeah.
That's fine, right?
Yeah.
Chalo, thank you.
Yeah, and one basic doubt that everybody was asking me in the chat. This project is for Y20 and Y21 both. So, and if anyone else is interested, they can contact us.
Any other questions regarding this project?
When will be the classes conducted for these projects?
That will be
Yeah.
decided by your mentors. Okay, if you have any general doubts like this that are not related to the specific project, please put them on our Discord channel and we will answer them there. So we'll start with the next presentation. Rohan, are you here for
Hello, Nupur.
regression analysis?
Yes.
Okay, great.
Is my screen visible?
Yes.
Okay then. Hello everyone, I'm Rohan. Topic for our project is regression analysis, which is co-mentored by me and my friend Sandeepan Mitra. First of all, what's the project's objective and learning goals? The importance of statistics cannot be undervalued at any domain, be it analytics, machine learning, business, or even product management. Hence, learning the important statistical tools keeps one at an advantage at any career field. This project aims to serve as a tool for several fields like data analytics, applied econometrics, model building, etc. Using real life examples in projects will help in learning the concepts better, and students will learn to apply statistical tools in programming. Now, what will this project cover? The main content begins with linear regression, first with one regressor and then with multiple regressors. After that, several important concepts like OLS, R squared, dummy variable concepts, etc. will be covered. We will then move to panel data regression and then time series analysis, which is an extension of linear regression with multiple regressors. If time permits, we will cover non-linear regressions too. We will be tentatively doing 3 short projects, which will be a real-life applications of the concepts covered. Students will be required to make statistical models and interpret the results analytically. Now, what are the prerequisites? There is no prerequisites as such, but a basic knowledge of probability and statistics would be a plus point. Therefore, students who are doing HSO 201 or MSO 201 would have a slight advantage. At the same time, for those who are not enrolled, as well as the Y21s, we would be sharing an introductory course for the same so as to have a level field for all. Now, time commitment. At least 2 to 3 hours a week for the next 7 to 8 weeks would be required. So that's all from my side. Thank you.
Are there any questions related to the project?
Yeah, one question. Will this involve programming or will it be totally on pen and paper?
It would involve a basic programming in R. The projects would involve that. And also for that, we would be sharing the course links.
Okay. Thank you.
Is there any more questions?
If not, let's move it. Next up, we have Vansh and Pramod. Their project is MCMC methods in Julia.
Yeah, hi. So Pramod is not available. I'll be giving the presentation. Is my screen visible?
Yes.
Yeah, sure. So let's go ahead. Yeah. So as the name suggests, let's first discuss what's MCMC. MCMC is basically Markov chain Monte Carlo. And the basic idea is to use Markov chains for employing Monte Carlo methods. So let's first understand what are Monte Carlo methods. So Monte Carlo is basically simulating a probabilistic event on computer whose results are difficult to obtain analytically. Let's take a very simple example. For example, you roll a dice, say infinite number of times, and you want to get the expected value of the draw. So, or maybe the average of the values that you'll get. So all of that stuff you can do using Monte Carlo. Like, it's a very basic problem, but this concepts becomes very powerful when you have to employ it to some really strange distributions. And the idea is to basically repeat the experiment on the computer so that the estimated result is quite close to the truth. And then what's MCMC? MCMC may our goal is to just estimate a particular integral. Now, the motivation behind estimating this integral could be uh, to just find this estimate, to optimize a function, to do anything. So the basic idea is again to draw an IID sample from some target density P of X, which could be high dimensional. Like it's not, X might not be just a scalar, it could be a vector. And then we replace this integral by the estimator, which is just the average of the function at those values. Just a second, my cursor is not moving. Yeah, so why MCMC? MCMC is like one of the powerful algorithms that have been surveyed as the great, like, which have a great influence on the development practice of science and engineering. Particularly in machine learning, these techniques are very helpful. And the Metropolis Hastings algorithm is just an instance of a larger class of sampling algorithms, which are Markov chain Monte Carlo, MCMC. And then how precise are the samples? So this funny meme just tells you that nobody knows that you are employing a Markov chain. After some particular draws, the samples kind of follow your target distribution. Just going ahead. Yes, so about the project. So MCMC techniques, as I've already told, solve integration problems, optimization problems in larger dimensional space. And these two types of problems play a fundamental role in machine learning. So this project will not only focus on the theory, but will also ask you to implement various algorithms, preferably in Julia. So the tentative list goes as follows. So first we'll be discussing some sampling methods, then some particular sampling methods like rejection sampling and importance sampling, which form the basis of MCMC algorithms. And then we'll go over to the basic Markov chain theory and the measure theory. And then particular algorithms like Metropolis Hastings, Gibbs sampling and all. And then we'll work on accelerating these algorithms. So basically, MCMC algorithms can be sometimes a bit slow. So there are some techniques which you can use to accelerate these algorithms. And then also we'll discuss how to use MCMC algorithms to kind of sample from intractable posteriors. So you don't even know what your target distribution is, but you just know some things about it. And how do you sample from such distributions is what we're going to look at. Now, the prerequisites, this is definitely an advanced project and requires a good grasp of probability and statistics basics. An acquaintance with Julia and R is a must, and we would want that you have a basic understanding of the concepts of MSO 201, CS 203, HSO, or any other equivalent course. The cursor is not working. Yeah, so we are the mentors, Pramod and me. And that's it. If you have any questions, please let me know.
Is this project available for Y21?
If you have a good understanding of, at least a basic understanding of probability distributions, expectations, and statistics in general, you're welcome. Like we'll take a screening test or we'll take an interview to know whether you're eligible or not.
Like this does not assume any knowledge of Markov chain, does it? Because the test is
yeah,
for
so
probability.
the Markov chain part is not like, I mean, of course it is important, but we'll cover it like in the project itself. So it's not a big
Yes, so if I have an understanding of what distributions are and how they work, like can I apply for the test at least for the screening?
Yeah, sure.
Okay, thank you.
I mean, Markov chains are not like a rocket science. It's just a simple concept that you can grasp very easily.
Yes, thank you.
If you're familiar with the probability distribution and expectations, but we're not very familiar with the Julia or R languages, then can we apply?
Do you have any prior experience with like any programming language, Python?
I'm
Yeah,
Or...
from the
yeah,
group. I know her.
Yeah,
yeah.
then you're free to
Yeah,
apply.
like we
No
know
issue.
some languages like Java or Python.
Yeah, then like learning R is not a big deal. You can apply for the project. Oh yeah, so coming on to the like time commitments, we expect at least 8 to 10 hours of commitment, like of weekly commitment, and then the project duration is like tentatively it's 14 to 16 weeks. Any other questions?
Okay, it seems there are no more questions. Let's move on. Thanks, Vansh.
Yeah,
Next
thank
up, we
you.
have Fahad Sheikh. His project is on quantum algorithms.
Yeah, so is my voice clear? All right,
Yes.
I'll start sharing my screen. All right, so this is my this is a project I'll be mentoring on quantum algorithms. I've done a similar project last year, and I would like it would be a kind of a continuation of that project. What not continuation? Most likely it will be a lot of similar. This project is mostly like a reading project where we will solve assignments from Nielsen and from a textbook called as Nielsen and Chung. So let me just introduce what is quantum computing. So one second. Yeah, so it is one of the research disciplines which has a full of promises, and in many cases, these quantum computers are very outperforming classical computers. And by because of research getting better day by day, there is a huge development and there is a huge like outperforming cases shown in quantum computers. So um, so the prerequisites for this project would be MTH 102, which is linear algebra, ESC 101, basics of computing, and I have marked Python and PSO 201 as a in blue because these are not prerequisites, but then they could be used as a boost. Like if you know these courses, if you know these modules, you know how to get around this project very easily. I have not decided tentative timeline as of yet, but then for there will be like the people under me will learn the basics of quantum for basics of quantum mechanics, and we'll just look into it one sec. Yeah, so these are the lessons to be covered. So first we'll try to look at the basics of quantum computing. It will have a lot of linear algebra, and so people have to be ready for getting their hands down into quantum mechanics. And then after we learn about this, we'll try to build quantum circuits, understand quantum gates. Like you have classical logic gates, you also have quantum gates, and we'll build circuits. And then we'll look into quantum algorithms, which is like, for example, I guess many people have heard the Shor's factoring algorithm and Grover's search algorithm. And then at last we'll use Qiskit. So basically Qiskit is a Python module. It's an open source software it is developed by IBM, and it is used for simulating quantum circuits, and to understand how quantum circuitry works, how qubits work better. And I feel like these three will be the most fundamental important parts to be covered in this project. And we will look into Qiskit if we have time, but then we will look into basics first, and then we can go deep into them later. So, and then next, so these are the evaluation techniques. So I would have a bi-weekly assignment from, as I have already mentioned, we'll be using Nielsen and Chung, a quantum computer and information tech, and I will give you weekly assignments, how much and how many you have to submit them for ratification. For midterm, I will give a theoretical assignment. You can either type it, or you can, even if you're good at LaTeX, you can type it, or you can just write it down and submit it to me. At the end term, this is tentative. You'll have a programming assignment on Qiskit and one theoretical assignment. And so the goals of this class is, of this project is, we have to grasp the basic knowledge of quantum mechanics, and then you'll get to know some knowledge of the quantum algorithms and circuits. And if you don't know Python, you'll be getting to learn some Python and Qiskit as well. So this is my project. Thank you. And if you have any doubts, you can always contact me on Discord. This is my username. And also about weekly time commitments, I would like the mentees to give around 6 to 8 hours a week. So yeah, I guess that's any questions?
Can students currently registered for MTH 102 take this project up?
Yeah. So basically, MTH 102 is a prerequisite. But then even if you don't understand, I feel like to Y21's MTH 102 is almost like the semester is about to end in April, right? Or March, this ending.
No, the first semester has gotten over. Just
Okay.
now
Second
the
semester
second
will end
semester
in
will.
April only. So
Second
yeah, till
semester.
April, last of April.
So you guys have covered up to linear algebra, I guess, up to now. You guys are going to start ODE. So yeah, you can take this project.
No, we haven't
will
started
start
our
on
second semester.
Oh, okay.
It will start on 23rd.
Then
Mid-sem exams are in May. So half of the second sem will end till May.
Okay, I understand. I feel like you could give it a try. Linear algebra is a good prerequisite, but then it is not completely like even in Nielsen Chung, the starting whatever material I give to you will not have that much of huge linear algebra. You just need to know some basics, like I guess matrices and vectors are a good example if you're familiar with it. Does that answer your question?
Yeah.
All right, sure.
Thanks.
Any more?
It'll be shorter than 4 months, right?
Yeah, it'll be shorter than 4 months. I would say. I mentioned it will be around 12 weeks, 10-12 weeks will be the
Okay,
time.
and will we have assignments during our exams, or like will we
Yeah.
be flexible with that?
Yeah. So whenever you have exams, like even I'll be flexible with that. Just drop me a message that you have exams, and then I will look into it. I still haven't gone into the grading assignment. It could be I could give you 6 assignments and only take 4 out of 6. It could be like that as well. If you don't want to, I will decide my final evaluation not later, not as of yet.
Okay, thanks.
Are there anyone questions?
No.
Then I guess I'll end it over here then.
Okay, thanks, Fahad. Next up, we have Priya, Abhishek, and Pradeep. Their project is number theory and applications.
Yeah. Hi, I'll be sharing my screen. Yeah. Are you able to see my screen?
Yes.
Okay. Hi, everyone. I am Abhishek, and I'm here to talk about a project which we are going to offer based on number theory and its applications in real world life. So, to start with a brief introduction. So this project aims to introduce the mentees to a branch of mathematics which is really old, called number theory, which primarily deals with integers and their fascinating properties. Like when I talk about properties, it can be in various different forms, such as finding like integer roots of a polynomial, or talking about prime numbers and how it is applicable in the real world scenario. Like there are a lot of applications of knowing particular features about prime numbers in the real world. So that's about it. Going into a bit of detail. So how are we planning to structure this project? The first part of the project would be theoretical, where we'll be talking about concepts related to number theory. And we would also like to introduce you all to basic group theory. which would be essential in the later course of the project. Uh, in this part, we'll be aiming to solve problems from different Olympiads or various sources just to get the concepts clear enough. Then in the other half of the project, we'll be aiming to learn about the applications of what we have learned so far and new technologies and new innovations in the field of number theory in applied areas like cryptography or random number generation or hash functions or like even floating point arithmetic. And there are a lot of domains. I think there's some noise. Good. So in this part of the project, we'll be basically implementing what we have learned in some way or the other by using some programming language. And this would be the main problem solving part of the project. So to brief you about the contents which we have planned to cover, we're basically dividing the whole project into 3 different components. In the first component, we'll talk about basic number theory concepts like divisibility, Euclidean algorithms, Chinese remainder theorem, and its applications, and various related theorems. We'll be solving problems on these topics to get your concepts clear. Then in the second half, we'll be talking about abstract algebra, wherein we'll talk about various structures like groups, rings, fields, and why do these structures come into existence. Finally, about the application parts. In the slides, I've listed some of the applications which we plan to discuss in a number theoretical manner, like primality testing. Like it basically means to test whether a number is prime or not. There are a lot of methods which follow a lot of different concepts related to number theory for that. Then random number generators, which is still based on number theory. Also cryptography and RSA crypto systems, which like number theory plays an integral part in RSA crypto systems, and we'll get to appreciate the logic behind these kind of crypto systems. Coming to the final slide about the duration and commitments. So we expect a basic of 6 to 8 hours per week time commitment, as this project might have some learning curve for people who are unaware about number theoretic concepts and who will be coming across these concepts for the first time. The expected duration of this project is around 2 months or 8 weeks, but we can extend the project depending upon the enthusiasm of the mentees. Coming to a part of how we plan to grade the projects. So we'll be providing you with assignments, which will be based on both theoretical and programming based questions to assess the progress which you are making throughout the course. And we'll be using those assignments as a part of ratifying you for the project. Essentially, there are no prerequisites for this project, but you need to have like some amount of mathematical maturity to appreciate the concepts which you're going to learn throughout this project. Then at last, it is mentioned that programming knowledge would be a plus point, but it is not a hard limitation or a prerequisite. We can learn the programming concepts as a part of this project. So yeah, I think that's it. I'll stop sharing. If you have any questions, let me take it up right now.
So which language would you be using for the problem solving part?
Yeah. It would be flexible, and we'll keep in mind what the mentees are aware about. We'd prefer Python, but it's not a hard and fast rule because it would come in a later part of the project.
Okay.
Yeah. Any other questions? So I think that's it. You can ask any questions if you have on Messenger or Discord. Feel free to do that.
Okay, so now we'll move on to the next project by Rahul Sethi, and an invitation to functional analysis.
Hi, yeah, let me just share my screen. Okay, cool. Can you see it?
Yes.
Yeah, all right. So as you already know, the project is about functional analysis, which is also offered as a course here at IITK, which is MTH 405. And yeah, let's get into the description and everything. This is roughly an overview of the things that I'll talk about. So first we'll talk about the description, then the actual topics that we intend to cover, at least some of them. And then what you need to know before you sign up for this project, the intended audience, which is basically Y20s for the most part, and the expectations in terms of midterm and end-term reviews. So you might have already seen the description, but I'll still talk a bit about functional analysis. So you might have taken MTS 201 in your last semester, which is just linear algebra, and functional analysis is basically linear algebra in infinite dimensions. So if you have a good grasp of MTS 201, you'll be able to understand the bigger theme of the subject. So in the first half, we'll talk about some general techniques in the subject functional analysis, and in the second half, we'll focus only on Hilbert space theory, and in fact, we'll only talk about separable Hilbert spaces. So I hope you're familiar with some of that. Then if we have the time and if you have the interest, then we can also talk about operator theory, and another research area that I'm interested in is the interplay of functional analysis and convex geometry. So that's also something we can talk about if we have the time. All right, so let's go into the topics. So we'll take a pretty unconventional approach here as compared to most of the basic texts in this subject. So first we'll learn about category theory, and you'll see why it is useful in the later part of the project. Then we'll take a very conventional approach from here on. So we talk about Banach spaces, some very basic results in functional analysis. Then we'll talk about dual spaces. You might have seen these in finite dimensions in MTS 201. Then weak and weak star topologies, and to understand that you need some basic understanding of what topology is and so on. And this is part one of the project roughly, and the second part is actually more involved. So we'll talk about Hilbert spaces, operator theory on Hilbert spaces, and if time permits, we'll also go into the spectral theory on Hilbert spaces. And I'm sure you have seen some of these things in 201, so everything won't be new. And so the prerequisites, so things that you need to know before you sign up for this project. So MTS 301 is certainly required, but if you're still doing it this semester, that's okay. I only need the first half of MTS 301 for the most part, and you can always learn it on the side. Then 2 and 3, which is basically general topology and some measure theory. If you know it, that's good. If you don't, then you can always learn the important bits on the side. So yeah, MTS 301 is a hard prerequisite. The other two are soft prerequisites. And LaTeX is something that you can always learn on the side. So it doesn't matter if you know it now or not, but you'll need it. So that's important. And if you have any questions about whether or not you satisfy the prerequisites, you can always email me, DM me, whatever. You can figure out whether this project is the right fit for you or not. And the intended audience, like I said, anyone fulfilling the prerequisites is welcome to register. I'll be happy to have you. But the project will mainly be of interest to Y20, MTH, and physics undergraduates. So I say physics undergraduates because functional analysis has a lot of applications in quantum mechanics. It will help you understand that subject better. In particular, Hilbert space theory forms a very important part of quantum mechanics. And Y21s are not encouraged to apply unless they have sufficient background. And in case you think that you do have sufficient background, please get in touch with me directly, and we can have an interview or something before you sign up for the project. And the expectations in terms of the end-term and midterm reviews or so on. So first of all, the weekly time commitment would be at least 10 to 12 hours per week. So this is going to be a heavy project. It will involve significant self-study, exercises, and also typing in LaTeX whenever necessary. And throughout, you'll be preparing an end-term report, which is mandatory, and a presentation or a viva is completely optional. So that's on you. You can let me know if you want one or not. And you might wonder what we'll do for the midterm report. So basically, the first half of the end-term report will serve as the midterm report. So that's about it. And I guess that's all I have to say. And you can always reach out to me on Discord, Twitter, or my email. And if you have any questions right now, please let me know. I'll stop sharing. So if there are no questions, we can move on to the next one, I guess.
Yeah.
Thanks.
The next project is Introduction to Proof Complexity by Farzan Bairam.
Yeah, hi. So can you see the screen now?
Yes.
Yeah. So I want to talk about proof complexity, and like this will usually mean propositional proof complexity, but we usually like drop the adjective propositional. So this is about propositional logic, and basically how long does a proof of a valid propositional formula have to be? Is there a way to can there exist short proofs of a particular statement or not? Okay, so the setting is that we have a bunch of propositional variables or atoms, an infinite collection of them. We have these standard connectives, not, or, and I'm being somewhat informal here for simplicity. And here's an example of a propositional formula. So we've got x1 here, and this clause not of x1 or x2, and similarly another clause and another clause. Yeah, so by clause, so this is this formula has a very special structure. It is in what is called CNF form. So you've got a conjunction of a bunch of clauses. A clause is just a disjunction of a bunch of literals. A literal is a variable or its negation. Okay, so these formulas with such special structure are also very interesting, especially in computer science. So so the question is, so this was so first we talk about maybe semantics of this thing. So if you plug in some values, true or false, to each of these variables, then this formula will either evaluate to true or false. Okay, and so we say that a formula is valid if it is true for all assignments. So the question is, so instead of plugging in all values and checking, is there another way? So that brings us to the notion of proof systems. So a proof system is basically a bunch of axioms and rules such that basically starting from these axioms and using these rules, you can derive any statement which is true. And so you would want that the only things you can prove are true, and all things which are true can be proved. So these are the two properties of a proof system that you want. And another property that will be useful, especially in this context, is that the proof should be easily verifiable. So what that means is, suppose I have a short proof, it shouldn't take me a long time to check whether it is indeed a proof or not. Okay. And so there are standard proof systems, things you might have seen in some logic course, so what we informally use in all mathematical proofs in some sense is the natural deduction system. But things that you would see in a logic course include Frege systems. So here as an example, I'll just talk about a very weak propositional proof system called the resolution proof system. Yeah, so resolution is slightly weird as a proof system, but so you instead of so the restriction here is that you can only prove DNF formulas, and so the way you prove them is by showing that the negations, which will be CNFs, are unsatisfiable. So you start with a bunch of clauses. So suppose for example you were given this formula and you wanted to show that this is never satisfiable. Okay, so you are given a bunch of clauses and somehow you want to derive the empty clause because the empty clause is never satisfied. Okay, so the rules you have are that if you have two clauses of this form where one clause contains a variable and another clause contains the negation of that variable, then you can combine the rest of the literals in those clauses and deduce this A or B. Yeah, so A and B are just clauses here. And the other rule is a weakening rule. So it's not obvious just now, but this system is complete for DNFs. I mean, it's refuting DNFs. So here's an example of how a resolution proof would look like. So for example, here we resolve on the variable x1 to deduce x2. Here we resolve on the variable x3 to deduce x2 bar. From these two, we can deduce the empty clause bottom, which is never satisfied. So this is about resolution, and this is a very weak proof system. So one would expect that there are tautologies for which, maybe I should say contradictions which are hard to refute in this. Hard in the sense that any proof would require a lot of lines, a lot of formulas in it on the way to finally getting the empty clause. So one such formula is, for instance, the pigeonhole principle for a suitable formulation of it. This was shown hard by Haken in the 80s. And so like this is one of the things that I would like to do in this, I want to call it, it's more like a reading group actually. So we'll be looking at certain topics and discussing them. Someone will be presenting things and so on. And there are several connections with other things. So yeah, so SAT solving is one of them. So resolution is in some sense equivalent to the famous DPLL algorithm for SAT solving. Then instead of looking at these kind of logical proof systems, one could look at other kinds of proof systems. For instance, those related to integer programming, for example, cutting planes. So that has connections with optimization algorithms. Then one could also talk about algebraic proof systems, such as the Null-Stalin-Sats and the polynomial calculus. So those are again based on ideas from commutative algebra and some basic algebraic geometry. And this also has connections with algebraic circuits, which are very important in TCS. So that, questions there are supposedly easier than in the Boolean world. And finally, this nice connection with Boolean circuits via some other areas. So if you start with, so this is like a general framework for a lot of recent results. So you start with a statement which is hard to prove in some proof system. You transform it to a decision problem for a decision tree or the problem of like querying the input to find out some to compute some function. And then you can lift this query problem to a communication problem. So transforming it into a problem which has to be solved by two parties. And then from here, there's a connection with Boolean circuits. So it's quite remarkable that starting from here, you connect through so many different computational models to finally get here. Okay, and circuit lower bounds are hard to obtain. So you have this rich web of various things that connect with this area. Yeah, and as far as like I said, this will be more of a reading group, right, rather than like a assignment based project where you are doing certain tasks as such. So the idea will sort of be that we'll read up on certain things, someone will present, and then we sort of discuss what we understand, how we should move on. Yeah, so I don't have very concrete plans, but those can be discussed based on who all are interested and who all finally sign up. And that's about it. Are there questions?
What are the prerequisites for this?
Yeah, so I'll say, if you've never seen propositional logic, then it might be somewhat weird. Yeah, so if you've seen some basic propositional logic, then that is the main prerequisite. You'll appreciate this a lot more if you have seen some computational complexity, although that's more for motivation and for appreciating all these connections. Again, so all these are highly domain specific. So if you are interested in one of these, you could look at those. Not everyone has to look at all of these and so on. So yeah, just a hard prereq, I'd say even that is not very hard because propositional logic is not that hard to pick up. So yeah, so that is the main thing.
So Y21s can apply for this, right?
Yeah, I mean, but again, you should get in touch with me first so that I can be sure that you won't face any trouble.
Yeah.
At least you can read up before we officially start, so to speak.
Yes. Yeah, I understand. Thanks.
Is it very much like Boolean algebra?
Yeah, that's sort of the basis of propositional logic. But the questions we'll ask here are beyond propositional logic. The question is more about how long do these proofs need to be? Although again, in between as intermediate lemmas and so on, you need the basics of propositional logic.
So if we know the basics of propositional logic, then we'll be able to do this.
I think so, yeah. Again, I don't expect many people to be interested in this, so that all can be worked out as long as you're actually interested in this. Yeah.
Time period for this project?
Yeah, I don't have very concrete goals, as long as people are interested, I guess. But we'll continue as long as the projects are supposed to go on. So mid-June. At least that long will take, definitely. Like the first couple of weeks, I think like we'll just sort of learn about like the different kinds of proof systems, and after that we'll look at the main results, like some proofs of them and so on.
You said we'll present and discuss things. So does that mean like we need to be free at some time each week or something?
Yeah, definitely. I mean,
okay.
like you'll have to. I mean, like the time will be like we'll be able to work out once people sign up, but like that will be the main part of the project, so to speak. Like you'll be reading up on lot of stuff on your own, but the main thing sort of like where you interact with other people and so on, and which will be sort of part of the evaluation.
Yeah, so if there are no more questions, I guess we can move on. So the next project is Insolvability of Quintic Equations by Ajay Prajapati.
So let me share my screen. Yeah, so my project name is Insolvability of Quintic Equations. So what this is all about. So we all learn in high school that if we have this quadratic equation, then we can find a formula for x in the terms of coefficients of this equation. So you may ask the similar question for cubic equation as well. And do we have a similar formula for a cubic equation? And most of you will not know it because it's very complicated formula, but it exists. And in fact, it was found way back in 16th century by this guy named Carnado, which says that if you have this cubic equation in this form, then its solution is given by this. The real root of it is given by this. And as you can see that it is more complicated than this. And if you have cubic equations in this form, then the expression is very much complicated, much more complicated. And similarly, if we have a degree 4 polynomial, then we have a very complicated expression as well. Yeah. But things get interesting when we move to degree 5. So people searched for around 250 years for a formula which for the root of a quintic polynomial or degree 5 polynomial, but they couldn't find one. And by the end of start of 19th century, people began to suspect that there is no such formula. And basically, this guy named Paolo Ruffini, made him the main mission of his life to prove the insolvability of this quintic equation, quintic polynomials, that there exists no such formula. And he basically, during his lifetime, gave many incorrect proofs. And one proof came particularly close, and this guy was able to correct that proof. And in the honor of these two, the theorem is now known as Abel-Ruffini theorem, which says that you can't have a formula for roots of a degree 5 polynomial. And what specifically we mean that there is no formula, that we are only allowed these 5 arithmetic operations, plus, minus, multiplication, division, and taking nth roots where n can be anything. Yeah, so this is done degree 5 polynomial. So now you may ask that what happens in degree 6 or what happens in degree 7? Like the proof for degree 5 was very hard to come up with, and so the proof for degree 6 how long it would take. And actually it turns out that the degree 6 polynomials are also insolvable, and in fact all higher degree polynomials which are degree greater than equal to 5 are insolvable. You can't find a root formula for roots of this polynomials. And basically this guy named Galois, he is a French mathematician. He gave an entirely new perspective on this problem, and by this perspective you can basically prove at one go that there is no formula for polynomials of degree greater than equal to 5. And in fact, this is what we intend to understand in this course, in this project. And yeah, and one interesting thing is that this fact about polynomials is a consequence of a group theoretic fact that we probably learn in first group theory course, that an alternating groups in n letters an is simple for n greater than or equal to 5. So this fact is the main obstruction in finding the formula for degree 5 polynomials or higher polynomials. Yeah, so we will be our main goal. So what we will be learning in this project is called Galois theory, in the honor of this guy. Yeah, so what are the main objective of this project? So the main objective is to understand the proof of insolvability of Quintic equations, and along the way we will see all these things like fundamental theorem of algebra and fundamental theorem of Galois theory. So you may not all know these things, but these are really cool things once you get to know them. And we will follow this book Abstract Algebra by Damit and Fute. And yeah, the prerequisites for this is linear algebra at the level of MTH 102. And also, we also required basic knowledge, some familiarity with abstract algebra, like group theory and ring theory. So this is intended for Y20 mathematics and computer science students. Y20 mathematics students are probably doing their abstract algebra course currently, and whatever they have learned till now should be sufficient to get start on this project. Yeah, if you feel that you have basic knowledge of abstract algebra, then you should contact me if you are Y21. So one thing is that this is a purely theoretical project. So you should take this only if you are really interested in learning this, like because this is going to be slightly advanced project as well. Yeah, and the evaluation method is going to be that I will give you weekly assignments and you need to submit your handwritten solution. The best way to learn mathematics is to basically practice more and more questions. Yeah, and as I said, that this is not for the first year student, because this is a slightly advanced project, and first year student will not have sufficient mathematical maturity. But if you feel like you do have, if you are familiar with basic abstract algebra, then you should feel free to contact me. So any more questions?
Does it have like any applications in physics that you know of?
No, I don't think so. No. But yeah, learning group theory is important in physics. Yeah. But this is purely for people who want, who are interested in number theory should definitely learn this. This is not for physics.
Yeah, thanks.
So any other questions? So I guess we can move on to the next project. That is Algo 101X by Satyam Kumar Roy, Shaurya Kumar, and Kuvarpreet Singh.
Hello, am I audible? Hello.
Yes, you are audible.
Yeah, I'm just sharing my screen. Is my screen visible now?
Yes.
Okay, so my name is Shaurya, and I am offering this project with Satyam Kumar Roy and Kuvarpreet Singh. So basically the area, like it is related to combinatorics, number theory, probability, and like discrete mathematics, and like it is related to programming as well. So basically, like first of all, like the intended audience for the project is like they should be familiar with one like in a programming language, preferably C++, but if even if it any other programming language will be fine. So, and they should also be familiar with like basic time complexity analysis. Like they should be able to like analyze time complexity of like for loops at least, and like they should be familiar with concepts like checking whether a number is a prime or not, or like things like finding all factors of a number. Like doing this using any programming language, well, either in C++ or in any other programming language will be fine. So like the contents like that we have like tentatively decided are like we will start with like basics of number theory and like applications of GCD in like basically we will give reading material as well as sessions will be taken by mentors on different topics, and there like regular contests will be like held on code forces or other programming platforms. So basically we will cover different kind of problems which are usually encountered in competitive programming regarding these topics. So first of all, we will begin with like number theory and GCD, and then we will also focus a lot on expected value problems and probability questions as they are like very common. Then we will move to hashing algorithms, like, and after that we will also cover like exponentiation, the binary exponentiation and matrix exponentiation. Like these things are very useful like for counting problems as well as in dynamic programming as well. Then we will like go back to some other topics from number theory like Chinese remainder theorem or Mobius inversion, and after that we will move towards like graph algorithms and like questions based on those. Usually like we will try to cover like dynamic programming applications in like connected components or stuff like that in graph algorithms as well. If time permits, we will also look at constructive problems or some strategy problems, and if further time permits, then we can also look at generating functions and like fast Fourier transform. uh, so basically to give a flavor of like what kind of problems we are going to cover, let's see some problems. So like first of all, as we will emphasize a lot on like probability problems and expected value problems, so what kind of problems do I mean by it? So suppose let's take an example. Suppose we have 10 cards at random from a set. We have to choose 10 cards at random from a standard deck of 52 cards, and we are asked that like on an average how many aces we will get if we take 10 cards at random. So basically it is saying that if I just take 10 cards at random from 52 cards, then what on an average how many cards am I gonna get? What is the expected value of number of aces that I will get? So there are some more examples which you can look at. So we will also cover like linearity of expectations. So suppose you like let's take one more example. So like there are n lottery tickets. The constraint is like 10 is to 5, but let's ignore this. So and it is said that the ith of them is winning with probability pi. So there are n lottery tickets, and we know that with probability pi, the ith of them is gonna be the winning ticket. So the question is like find the expected number of winning tickets. So that kind of questions. Then in number theory and GCD, like the questions will be like suppose you are given a list of n positive integers, and your task is to count the number of pairs of integers that are co-prime. So basically there is an array of n positive integers, and you have to find the number of pairs such that they are co-prime with each other. So similarly, you can be also asked like suppose there are n positive integers, and you can be asked that uh, what is the greatest common divisor if we take pairwise all the like if we consider all the pairs from the array. So then for counting problems, there can be a question like suppose you are given a graph. Like if for those who are familiar with what graphs are, so if you are given a directed graph with n nodes and m edges, then it could be asked that find the number of paths from a particular node to some other node with exactly k edges or something like that. So then there can be more problems on like number theory GCD. Like you can look at these after like as shared will be slides will be shared with you. Then we will also look at like probability, like because dynamic programming is like a versatile technique, and it is used quite a lot in solving probability questions as well. So like so we will look at such these kind of problems as well. So in this problem, like just we can see that suppose there is Takahashi is participating in a lottery, and each time he takes a draw, he gets one of the n prizes available. So there are n prizes available, and he gets one of them whenever he takes a draw. And the probability of getting the ith prize is wi upon sigma wi. So, and the results are draws are independent of each other. Basically, the consecutive draws are independent of each other. So like the question is like, what is the probability that he gets m different prizes from k draws? So basically you can see something like there is some modulo and something like that. So we will also cover like modular arithmetic and like how to basically it is used so that there is no overflow while we are solving in a constrained environment. So we will look at this as well. And so basically tentative plan will be like study material will be shared as well as like in form of blogs and problems, and sessions will be taken by mentors, and like practice problems will be given, and the main part of the evaluation will be like weekly mashup contest will be there on different platforms, and time commitment for each week will be from 4 to 5 hours, uh, and like it will help you to like building aptitude for like problem solving, and uh, it will definitely improve your competitive programming skills. And like we have also heard that expected value problems might show up in quant interviews as well. So I think that should be all from my side now. If there are any questions, then we can answer for sure.
Could you show the study plan, the tentative study plan, like what the plan is?
You mean the topics, right?
No, the evaluation scheme, I mean, sorry.
Yeah, evaluation scheme will be based on your participation in the weekly contest, that like the number of problems you solve there on the contest and your participation on those contests.
Okay, okay.
So this course is basically geared towards competitive programming, right?
Yeah, it is basically like we are using it as a tool for studying these topics. Yes.
Okay. And what are you going to cover in graph algorithms?
Like we can like it depends on like what background the people have that those join in the like. So basically if we go with like there can be different spectrums, like so it is not completely decided what exactly we will cover in graph algorithms. So it depends on like how the project goes.
So if there are no more questions, I guess we can move on. So the next project is Introduction to Deep Learning in Applications by Ashutosh Sharma, Prateek Sogra, and Vineet Kumar.
Hello, am I audible?
Yes, you are audible.
Okay. Is my screen visible?
Yes.
Okay. So, hey everyone, this is Ashutosh Sharma. I'll be one of the mentors for the project Introduction to Deep Learning and Applications. So, there's something about the project what we will be telling now. So, this project will be a basic introduction about deep learning practices and all the maths in different algorithms and concepts used. Also, we would be teaching you about computer vision. Computer vision exactly is exactly I can say like we will be teaching you how do we interpret data from images, extract that data, and interpret and come up to some results. Okay. So now these are the contents for the project. We would be starting with some linear algebra and mathematics or some calculus that would be required for the project. Then we would be proceeding with the Python libraries and data visualization libraries required. Then we would be teaching some we will be introducing you to neural networks and how to train them, design these neural networks, and concept related to that. After this, depending upon the participation and enthusiasm showed by the mentees, we would be teaching further concepts. Also, we would be teaching the concepts as mentioned of regarding the computer vision part. And in the end, we would be expecting a submission from all the mentees in the form of a project. Currently, we have finalized SGS solved segmentation challenge, but this can change with time. Okay. Now, prerequisites for these projects: familiarity with Python is compulsory. The extent I can explain is around the programming concepts that you learn in ESC. Or if you have some doubt, you can always reach out to me about are you satisfying these prerequisites or not, and basic mathematical aptitude to understand matrices and related mathematical operations. For the time commitment part, it would be around 8 to 10 hours, and we would be expecting self-study from your end, because we would be providing a lot of study material, and we would be taking some sessions bi-weekly or weekly. That would depend on the time. Also, the evaluation would depend on the assignments that you'll be giving. There would be so you will have to complete more than 75% of the assignments, and also the project submission that I mentioned in the previous slide would be compulsory as an interim evaluation for the project. So this is all from my side. Now I'm open to questions.
What is the difference between this one and the machine learning course that is also there? Because even there, also there is a neural network, a lot of the same topics, linear algebra and everything.
So we would be mostly focusing on the application part, and basically in the machine learning project, you would be having regression and all those algorithm part. We would be focusing on CNNs, RNNs, and other concepts. Also, we would be focusing on computer vision part more in this project. So in this way, it is different.
Okay.
Is it open for Y21?
Yes,
I am
it is
currently
open for
learning Python, but I am familiar with programming basics. So, am I eligible for this?
Sure. You can reach out to me about what doubts you have in programming and how much knowledge you have till now. We can talk about that.
Okay, thanks.
Any other questions?
So if not, so then we can move on. The next project is Decrypting Technical Indicators by Sujal Harput, Sheetal Gupta, and Sara Kapoor.
Okay, I'm expecting the screen is visible. Yeah.
Yes,
Okay.
it is.
Yeah. So our project is Decrypting Technical Indicators. So this basically deals in technical analysis of stock market and crypto exchanges. So what are technical indicators? So a technical indicator is a mathematical calculation based on some historical price, volume, or data that seeks to forecast financial market and technical analysis. So basically, we intend to predict the stock prices or crypto prices in the future by using the past data which you have in. So this is the basic idea in which we'll deal in the project. So the example of this could be seen is like the candlestick method of the Bajaj Finance stock. As you can see, you can see on my cursor, these are the candlestick patterns. So these are some indicators we have used in. The gray one is a Bollinger Band, and trend indicator RSI, and this red line is moving average. So basically, these terms might sound new to you, but we will teach these terms and we would make you feel how to read this graph, and how you can say this time would go in the future, or how this will go. We'll just learn this in this project. So it just helps to smooth out the data. The many stocks this indicators help us to smooth out this data for us, and it helps us to learn how the stock and crypto will go in the future. And this also acts as an alarm for any kind of volatility. If stock breaks a support or resistance, in that case we get to know this. So what we intend to cover in this? So we will start off with some basic indicators like MACD, RSI, moving averages. We would go on with the mathematical derivation of that, and we would then backtest on standard indicators, standard exchanges like Nifty 50 and crypto exchanges like Bitcoin, Ethereum, or Cardano. This is we intend to cover. So our tenure timeline would be like in the week 1, we would teach the basic terminologies of stock market, like reading the candlesticks and different terms like longing, shorting, and other things. In the week 2 and 3, we will go on with some basic overlay indicators These are some basic indicators which just depend on one line, like moving averages or RSI. Then we would backtest the overlay indicators. By backtesting, I mean we would test it on Python, or if you don't know the Python, if in case, they would test on some platforms like Option Alpha or Mudrex. But I would prefer that you learn Python if you have interest, and that will be much better. Then the week 5-6 would go ahead on oscillator indicators, and then we would again backtest oscillator indicators in week 7, and then we would combine both overlay and oscillator indicators in one strategy and check on which stock and on which pair we get the best returns. Expected workload would be 5 to 7 hours a week, and prerequisite asset are as such none, but knowledge to ESC 101 could be just a bonus point, as if you can code in Python in future then. So that's it from our side. You can reach out to any of us, and if you have any questions, you can ask.
Yeah, so any questions regarding to that project? Moving on. So the next project is connecting the first search by Utkarsh Jain, Aditya Patil, and Saransh Agarwal.
Our project is on graph algorithms and data structures based on graphs. We will start with time complexity analysis and with getting familiar with C++ and HTL, as it will be used for implementing algorithms. Then we will start graph algorithms with searching algorithms, depth first search and breadth first search. After that, we will move on with algorithms to find shortest path and minimum spanning trees. We will also have a look at various data structures based on trees such as heap, segment trees, family trees, and disjoint set unions. As time permits, we may have a look at topological
Excuse me.
components and
Yes,
You aren't audible. We can't hear you.
that's so. It- ऐसा क्या बोला? Am I audible now?
Yes, you are.
Right. So I think we should start from the beginning.
our project is on graph algorithms and data structures based on graphs. We will start with time complexity analysis and getting familiar with C++ and HTL, as it will be used for implementing algorithms. Then we will start graph algorithms with searching algorithms, depth first search and breadth first search. After that, we will move on with algorithms to find shortest path and minimum spanning trees. We will also have a look at various data structures based on trees such as heap, segment tree, family tree, and disjoint set union. As time permits, we may have a look at topological sort, strongly connected components, and dynamic programming on trees.
So we are definitely expecting some familiarity with either C or C++. If you know HTL, that is good, but that is not a hard prerequisite. And moreover, you should have actual interest in mathematical proofs, because we will be proving the correctness of every algorithm we discuss. So the time commitment will not be much. We are only expecting about 5 to 7 hours a week. We will cover about 2 concepts each week. And if the mentees show interest, we can go further than currently planned. All right, that's it.
Yeah, so any questions regarding this project? Anyone?
what will we be doing in C++ in this project? What will we be using C++ for in this project rather?
Basically implementing the data structures and the algorithms that we learn about. Like this is not like a like the major part of this project is theoretical, but you should at least implement each thing at least once, right?
Yes. I understand. Yeah.
So is that it? So we can now move on to the next project, Number Theory and Cryptography by Piyush Bigala, Biplav Kumar Tiwari, and Sujay Sat.
So is my screen visible?
Yes, it is.
Okay, so the name of our project is Number Theory and Cryptography. And so the aim of this project is to introduce you to some amount of number theory and algebra and a few other things which will help you in understanding some cryptographic techniques. So coming to number theory, so those of you who don't know, number theory is a branch of math which deals with some properties of natural numbers, integers, and rational numbers in some cases. So for a long time, it was considered to be useless, but with the advent of computers, it has found a lot of uses. And in particular, cryptography is almost completely based on number theory. So we'll talk about it. And in particular, so talking about cryptography. So cryptography is a study of processes through which you securely encrypt and decrypt messages so that nobody else can intercept and read it. So whenever you log into your email, you log into Hello IITK, you use it everywhere. So coming to the content, we'll start by studying about some elementary number theory. So we'll study about some congruences, and we'll talk about Euclid's algorithm, Bezos' lemma, and modular inverses, Chinese remembering. And then we'll talk about totient function and some properties of Mobius function. And then we'll study a bit of algebra. We'll talk about finite fields and quadratic residues. And then we'll come to some application parts. So we'll study about primality testing algorithms. And those of you who do some comparative programming may have heard of Miller-Rabin test. So it is a probabilistic algorithm to test if a number is prime or not. So we'll study about it. In fact, we'll see a probabilistic analysis for why it works and with what accuracy it works. And if we will get time, we will also talk about integer factoring, which in general is a tough problem, but we'll see what we can do. And then we'll talk about RSA, Diffie-Hellman key exchange, and then we will also introduce you to elliptical cryptography. So before ECC, we may need to study a bit about projective geometry. So projective geometry is also a very interesting subject. Using it, you can answer some very nice problems. For example, you may have heard of some problems like if you have a straight line and you have a point, and you just have an unmarked scale and a pencil, then you cannot construct a perpendicular from that point to that line. So these kinds of things you can prove using projective geometry. We'll talk about a bit about it because we don't need a lot of it, but we'll talk about it. And then we'll talk about integer factorization problem and also elliptic curve discrete logarithm problem. So the security of RSA and ECC relies on the toughness of these problems. So we'll talk about them. And going to the logistics, the expected duration for the project is about 2 to 2.5 months. And we will expect you to work for about 4 to 6 hours per week. There are no prereqs as such, but if you like maths, then it's good enough. And we may ask you to implement a few things like, for example, Chinese remainder theorem or Miller-Rabin test. So some prior exposure to C or C++ will help. And these are the details of mentors. You can contact us in case you have anything to ask. And so, yeah, that's it. In case you have something to ask right now, you can do so. I forgot to say, this is for Y21, so you can feel free to apply.
Excuse me.
Yeah.
In place of C++ and C, can we use Python as well?
Yeah, of course, any programming language will work.
Thank you.
Anything else? If not, then I'll stop sharing and we'll move.
Yeah, we can go ahead. So the next project is Introduction to Game Theory and Auctions by Panchal Rastogi.
Hello, am I audible?
Yes.
Yes, I'll share my screen. Yes, so hi everyone. The project title is Introduction to Game Theory and Auction Design. So firstly, I'd like to introduce you to what exactly is game theory. So I'd like to explain that via a game. So for example, assume that there are two friends who want to, who are doing a good project. So the half of the project is almost done, half of the project is done, and tomorrow morning is the deadline to complete the project. So each of the friends who are in the group, they have an option, so whether they can do a night out and or they can sleep away and just obtain half of the marks. So as half of the project is already done, so they can anyways get decent marks. So these are the two actions that each of the friend can have. So this is a payoff matrix which can be modeled. So as you can see that if both of the players do a night out, then the happiness level would be 4,4. So for example, if because they are able to get full marks in assignment, but they are losing out on their sleep. And if one of the players sleeps and other spends a night out, then the one who sleeps is at happiness level of 5, because he's able to sleep as well as get full marks. So that's and other player is at 0 because he's mostly frustrated about as he has to spend a night out. Then similarly, we have if both of the players sleep, then the utility would be 1,1, as they are anyways getting only half of the marks. So this is the game that has been modeled. So if they are both kept in separate rooms and asked individually what they'd like to do, then and they can't have any contact with each other, then there's just a question that you can maybe ask, that which of the following would be the strategy that they'll choose, whether both of them will sleep, whether one would spend a night out or one would sleep, and what would be the equilibrium strategy. So as it turns out, sleep is the equilibrium strategy in this case, because if we assume that player 2 does a night out, then player 1 is better off when he sleeps, because he's getting a utility of 5 when he sleeps and 4 when he's doing a night out. And other case, when player 2 is sleeping, then also player 1 is getting a utility of 1 when he sleeps and 0 when night out. So as you can see, this is the equilibrium case, which might be surprising to you. So basically, game theory, to sum it up, is a modeling of the actions of some rational players who play according to some fixed rules. So the topics that we learn in first half of the project would be strategic game, best response functions, and concept of Nash equilibrium, dominant strategies, and we'll mostly see its application in economics on some models of oligopoly, and also mixed strategy Nash equilibrium. Then we also have the topic of auctions. So auctions, you can maybe imagine a situation in which all of you might have heard of auctions. So auction is basically, for example, if there's an ancient lamp which is up for an auction, then you assume n bidders who are willing to buy that lamp. So bidders will then submit their bid based on how much they value. So for example, if a person values it highly, then he may submit a higher bid. Then there will be an auctioneer who will collect all these bids and decide amongst all those bids who will be the winner of that auction. And then winner will need to pay an amount to obtain that lamp. So this is basically an auction. And there are various problems that arise in this space. The task of an optimal auction is basically to maximize revenue for the auctioneer. And also the problem that basically arises is that you can't always incentivize bidders to speak their true valuations, speak their true values. So we'll be looking at optimal auctions and how to design an optimal auction. So we'll start off with first and second price auction, then the revenue equivalence theorem, and the assumptions that are in place in an auction. And also we look at Myerson optimal auctions and non-independent auctions. So although there is no prerequisite, but some basic knowledge of expectation and probability distribution would be great. And you can also learn it along the way. It's open for all, and by 20 months are preferable for this project. Time requirement is 6 to 8 hours, and we will extend to 2 months. And these are the books that we'll be following, and you can reach out to me if you have any doubts or ask it now. Yeah, stop sharing.
Yeah, so if there are any questions regarding that project, you may ask. Otherwise, we can move on. So the next project is Introduction to Automata Theory by Nupur Jain.
Hi everyone. This project is going to be an introduction to automata theory. So an automaton is basically a mathematical model for computation. I'm going to be very rough with what I say in this presentation. So you may have heard of Turing machines. They were formalized by this guy, Alan Turing. And you may have heard that a Turing machine is a universal computer, which essentially means that if you have a C program, then the Turing machine can run it, and vice versa. But a Turing machine is basically just an infinite tape with some cells and some symbols written on it. And it has a head that can read and write on the tape, it can move around on the tape, and it can store some information. Now, how can something that sounds so simple perform the same things that a computer can? And that is something that we will look at in this project. What can a Turing machine compute? What can a Turing machine not compute? How do you define it formally? How do you build a Turing machine for a particular algorithm? Things like that. So we might touch upon some complexity theory after we cover this. Before we go to Turing machines, we would be covering some more basic forms of automata, such as finite automata. So this is what a finite automata looks like. A finite automata basically recognizes a language, right? So if you input a string to it, so just a series of characters, it will process it somehow, and it will tell you whether that string is a valid word in the language or not. And something interesting is that the language recognized by one of these is exactly something that is generated by a regular expression. So some of you may have used a regular expression. It is useful to search for patterns in strings and things like that. So for example, this is a regular expression that can recognize whether a string is an email address. So yeah, this project will consist of regular meetings, and you will have some assignments. I will give you some assignments to do. They will be quite simple, so that should be okay. There are no prerequisites for this project. I am targeting Y21 and Y20. We will be covering, we will be using some techniques from step theory and logic, but we can easily pick them up along the way. These techniques are usually taught in like a basic set theory course like MTH 302. Yeah, automata theory is a very accessible subject, and it's quite fun to study. If any of these machines that I talked about just now interested you, then you can take up this project. Right, any questions?
So if there are no questions, we can move on, I guess. Yeah. So the next project is Quantum Theories and Applications by Bhumi Chaudhary.
Yeah, I'll share my screen. Yeah, so quantum theories and applications. We'll go on to the objectives. So the objective is that we'll start some basics of classical computing. Then we will move on to informal understanding of the quantum mechanics. Combining both, we will start with the basics of quantum computing. After we are comfortable with it, we'll move on to phenomena like interference and entanglement. And through some simple and fascinating applications, I'll try to explain them to you. Finally, when we are done with the basic theorems and algorithms like Shor's and Grover's, we'll move on to coding some of those theorems using IBM's Python library, Qiskit. Now we are analog beings living in a digital world facing a quantum future. So to understand that quantum future, I have a video.
The tantalizing promise of quantum computers is that they can do certain tasks exponentially faster than classical machines. And the quantum supremacy experiment is proof that this is indeed the case.
The word quantum computer is a little bit misleading because it sounds like a computer. And when people think of computer, they think of a phone or a laptop. The truth is the phone and the laptop and even a very powerful supercomputer all operate according to the same fundamental rules. And a quantum computer is fundamentally different.
The classical bit stores information as a 0 or 1, and a quantum bit can be both 0 and 1 at the same time. If you have 2 quantum bits, then there are 4 possible states that you can put in superposition. With 3 qubits, it's 8, 4 qubits, it's 16. It grows exponentially.
The nice thing about quantum supremacy is that it is a very well-defined engineering milestone.
In a nutshell, what we're trying to do is we're trying to show that experimental quantum computers can surpass the best supercomputers in the world.
To actually demonstrate quantum supremacy, we have these 3 steps. First, pick a circuit. Second, run it on the quantum computer. Third, simulate what the quantum computer is doing on a classical computer. We gradually increase the complexity of that circuit. At some point, it becomes completely impossible for the classical computer to keep up.
Yeah, so moving to why do we need to do a project on quantum fundamentals? So quantum computing is a nascent field and is seen as a way to revolutionize the world. Since, as I was already tried to explain, what is the quantum future? Now, quantum mechanics is seen as a more fundamental theory than Newtonian mechanics or the classical electromagnetism theory. Now, it provides an accurate and precise description for many phenomena that is classical theories simply cannot explain on atomic or subatomic level. And I did a project under the same topic last year, as I found it really a fascinating combination of mathematics, physics, and computer science. So, and it also helped me to actually think outside the box. Now moving on to the prerequisites. Since I mentioned it is a combination of mathematics, coding, and physics. For the mathematical part, we need linear algebra, complex numbers, vectors, and probability. For the coding, you need simple coding in Python, like you should know the basic syntax and basic debugging in it. For the physics part, you need a simple understanding of phenomena like double slit experiment. I assume you know it since your JEE times. Now these are strict and can be covered along the timeline. I'll be sharing the resources. Now the major advantage of using a quantum computer over a classical computer is that it has that speed. But there are several questions that come up, like can we make a computer game run fast, or can we have better graphics or browse the internet faster? So the answer being for now is no, that we cannot use quantum computer for such like general uses till now. We will try to solve some specific classes of problems which it can be used to solve, and has a huge advantage over the classical computers. We can also, since quantum computing is widely used in cryptography, we can also solve some puzzles or problems in it. Moving on to the plan. So I'll be providing you with weekly assignments. There will be a midterm and an end term test or an assignment as well. This project will take almost 10 to 12 weeks. I expect almost 7 to 10 hours of commitment per week from you, and the book referred is mentioned here. That's it. Thank you.
I wanted to ask one question regarding the linear algebra given over here. Is it the JEE level linear algebra or is it the college one, like Math 102? Is it that one or?
It's basically the Maths 102, but the JEE one is enough for having a base. For a base, then I'll be providing you for the resources. Can help you out with it.
Okay.
Any other questions?
Yeah, I guess we can move on. So the next project is Statistical Simulation by Ananya Kumar and Naveen Kumar.
Hello. Hello.
Yes,
Oh,
you are
hello.
audible.
Yeah. So I will ask Naveen to share the screen. One minute, just. So can everybody see the screen?
Yes.
Yeah. So, okay, I am Ananya Kumar Bhartri and my friend Naveen Kumar Mathur. We are going to take a course on statistical simulation. So, this is under the probability and this comes under the topic probability and statistics. And first I'm going to describe what all we are going to learn in this course, and then I will move on to what uses statistical simulation has in real life. Okay, so the first part, we will be conducting this project in 4 parts. So the first part will be introduction to probability and statistics. As I believe that most of the people here are Y21, so they may not have done courses like MSO 201 or CS 203. So this will be helpful for them because I don't think random variables are taught in 12th. So the part 1 of the course will explain what are random variables, what are the differences between continuous and discrete random variables. Then we are going to indulge into multivariate distributions and conditional probability based rule, which we have seen in 12th also, I believe. And the most important of part will be the change of variable formula, as we will be using it very regularly in the upcoming parts. So Naveen, can you move to the next part? So then in the part 2 of the course, we are going to see the various sampling techniques. So what is sampling? As I assume that most of you don't know what sampling is. So whenever we are dealing with some distributions, probability distributions, if you are aware of, we need some inputs, we need some output from that distribution. So sampling techniques help us to draw samples from some probability distribution. We will be covering this in detail in the part 2 of our course, and we will be looking at the major 4 sampling techniques which are regularly used, which are inverse transform, rejection sampling, Box-Muller method, and ratio of uniform. Then in the part 3, Naveen, aage kar sakta hai? So, and Then in the part 3 of the course, we are going to indulge into more complicated simulation techniques, which are used in industry level problems. And these techniques are are also used in ML and AI, even in deep learning. So this is a mixture of 2 or 3 components, and we will be teaching all of those. And this part will be especially interesting because we will be indulging into coding, and we are going to use one of the most famous library, TensorFlow, which is like kind of regularly used in industry. So if you are interested in ML or AI and want to learn about TensorFlow, you can join in join in this project also. And we will be doing some using TensorFlow. We will be doing some samplings, which will be RNVP and mean approximation. Naveen, part 3 part 4. So now this is the crux of sampling. Why do we need to sample? We need to sample from a distribution to apply a Monte Carlo method. So this is a very famous use of Monte Carlo is one of the problem, if you have heard about the Monty Hall problem. So what is a Monty Hall problem? So there is an American game show in which there are 3 doors, and behind one door there is a car, and rest behind 2 doors there is a goat. So what happens is you are asked to choose one of the door, and then the host, which is Monty Hall, he opens one door which contains a goat out of the rest 2 of the door. Then you are asked if you want to change the door or you want to stick to the door you have picked. So this was one of the most famous problem which was proposed, and people regularly think the standard way of thinking is like, it does not matter if you change the door which you had picked already. But it was shown by Monte Carlo that it matters if you change the door. And I will be in detail discussing how we can apply Monte Carlo to various other situations which are similar to it. And using that, we are going to using Monte Carlo, we are going to do simple importance sampling and weighted importance sampling, which will be very useful for calculating averages and expected values. Now, आगे कर लें. So all this course is open for everybody who is interested to learn about statistical simulation, and a little knowledge of Python code will be helpful if you are especially interested in the TensorFlow part, because it is a Python library. And don't worry if you have not done MSO 201 or 203. LCS 203, as we will be teaching the basics from start. Aage. And the expected duration of this course will be 6 to 8 weeks, and weekly commitment will be 4 and 5 hours. There will be regular assessment like quizzes, and obviously there will be some interesting coding questions which will use TensorFlow. So hopefully you find it interesting. Anybody has any questions also?
Yeah, so no questions. I guess we can move on. So the next project is Geometric Mechanics by Mohammad Saad.
I hope I'm audible.
Yes.
So, good evening, everyone. I'm Mohammad Saad, and this is my project on geometric mechanics. I'll keep the presentation short as it's been quite a long time now. So the project basically arises from my disappointment of the classical mechanics course here at IITK. And I did a similar reading kind of in my second years, and I pretty much liked it. So that's what I want to carry forward. So yeah, here's a nice quote by Stephen Hawking based on geometry. So the project overview, basically, like all of you would have done 5102 by now, at least half of you, or half of the Y21s. So basically in this project, I would like to cover where does the actual thing take place in a mathematical way. Like if there's a pendulum swinging, so we can say it's swinging, but where do the dynamics, where the equation which you write, the Newton's law, the equation of motion, where do they actually play with each other? What's the basically the stage? So the project would be aimed at studying that stage. So like the question, where does the dynamics takes place? And Y21 might not be knowing, but they are we define two functions, like the Lagrangian function and the Hamiltonian function, and respectively their formalism. So where do these functions actually live, in what space, and how significant are the symmetries in physics? There's a very profound theorem called Noether's theorem, which basically brings out the importance of symmetries in physics. And again, as usual, since this is a Stamatics project, we would be dealing heavily with the mathematical background of the physical framework, such as if I have to say a few terms. So while studying the Lagrangian formalism and the Hamiltonian formalism, there would stuff would come around like the commutator brackets, and such as one form, two form differentiable forms. And there's like the concept of manifold, the tangent bundle, the cotangent bundle. So just not to scare you all of you with these terms, but we would be going through all of this. In this project, we won't be solving any problem, let's say a pulley cart problem or a very tough rotational dynamics problem, because that's what you would do in your 5102, or would have done in your 5102, and the physics student would do it in the core 5401 as well. So that's not my aim, and that's completely out of my taste as well. So we would be basically dealing largely with the theory and the mathematical framework basically. And along with that, since I believe it's important to know the history and the background of whatever you are studying, like the equation, how did it come into being? What was the historical and philosophical background? So yeah, that would be like the recreational part of the project. The prerequisite would be basically, of course, an interest in learning theoretical mechanics and the maths. So for the projects aimed at for the UG Y20s and the Y21, I assume just a basic familiarity with classical mechanics of the level of at least 5102, just so that you know the stuff. I don't have to teach you the Newton's law from scratch or something. So just the basic stuff. And I hope the mentees would be motivated enough to at least do a certain amount of self-reading as well, because that's of course necessary. And yeah, interest in history and philosophy would be a bonus. That would basically boost your interest in the project. And in case the math gets too high, so some digestive pills for the math, but that won't be much of a problem, because there would be I hope to keep a good balance between the both, between the two, since at the end it's physics. But yeah, when we would do math, we would properly do the math. So that's basically the prerequisite part. The project would require, let's say, about 2 to 4 hours in a week, and I propose to keep it up to 6 or 7 weeks long. And of course, the pace would depend on the unanimous decision of the mentees. So that would be the project from my side, and feel free to ping me on Discord. By the way, I'm Automata, and the co-mentor is Rahul Keswan. I guess he's unavailable right now. So you can ping any of us on Discord in case you have any doubts, or you can ask right now.
Yeah, so is there any question? So if not, then we come on to the last project, and that is Rational Points on Elliptic Curves by Daud bin Mansoor and Udit Narayan Pandey.
So hello all, I'm Udit Narayan Pandey, a third year undergrad in Electrical Engineering Department, and I, alongside with Dawood, I'm offering this project that is rational points on elliptic curves. So actually Dawood will have the slides, so he will present it. So basically, I'm giving you an overview what the project is all about. So we will study in this project. We will study curves basically, and we will study some points on the curves which have the properties, which have some certain properties. Basically, we call them the rational points. And those points form a very nice algebraic structure. They form groups, and there are nice properties about them. And we will introduce you to all those properties. We will also give you the background that is required, the algebra that you need to understand those things. And we will give you a basic introduction of those rational points, their properties, some theorems and about them. And basically, we will in the end we will also tell you how these rational points are used in basically cryptography, but why their structure is useful. We can exploit their structure to in designing cryptography applications as well. So I hope Dawood had joined by now, and he would continue from here. Dawood?
Yeah, just give me a minute. I'm trying to connect. Yeah, just I'm going to share this. Yeah, so okay, so we'll quickly discuss the content, evaluation, the duration, the prerequisites of the project. So the project title is the rational points on elliptic curves. So first, what are rational points? So given any algebraic curve, which is, let's say, which has coefficients in rational numbers. So this is a polynomial function inside qx comma y, if you know some ring theory. So the rational points are specifically q tuples x comma y, so that x and y are both rational, and f of x comma y is equal to 0. Basically, all the points on the curve, algebraic curve, where both the coordinates are rational, right? So we'll be considering, we'll be studying the rational points on algebraic curves. We'll begin. Yeah. So what are elliptic curves now? So elliptic curves are a specific kind of degree 3 curves, which actually generalize almost all degree 3 curves. Yeah, and so we'll be defining elliptic curves and studying them throughout the duration. An interesting link between this is between the Pythagorean triples. So for given any Pythagorean triple, we know that a comma b comma c. So we know that c square is equal to a square plus b square. If we divide by c everywhere, you get the thing a by c whole square plus b by c whole square equal to 1. So one actually notices that a by c and b by c are actually rational points on the unit circle. And this is not only a one-way thing. There is actually a one-to-one correspondence between the rational points of the unit on the unit circle and all the Pythagorean triples, all the primitive Pythagorean triples in which there is no common factor between a comma b comma c. And yeah, so we will also be studying that, deriving all the Pythagorean triples. If you know all the Pythagorean triples already, we'll see an alternate proof for that. Yeah, right. And secondly, now yeah, so this is the how the at least this is something that we must cover in the project. So we'll begin with degree 2 curves, right? So we'll degree 2 curves is very well studied, and so we'll completely study them. Then degree 3 curves there's not much nice structure over them, and so but yeah, so there are results on it, but not as good as degree 2 curves. We'll go on to the Weierstrass normal form, which is basically elliptic curves, and then we'll give a group structure. So group structure basically means that given any two rational points right on the curve, we can get another third rational point. Right, so this will give an operation on the set of rational points of a curve, and using that operation we can define a group on this set, right? And so and finally we'll prove Model's theorem, which basically states that this group that we have is actually finitely generated. And yeah, so this is a significant theorem. So this is something that we must cover in the duration of the project, and we'll proceed in the project. Yeah, we can cover further depending on the interest of the mentees and the duration and the time left. Right. Yeah, so evaluation, we'll have at least one presentation. Yeah, so we'll and we'll have small assignments throughout almost for every meeting. And yeah, other than that, there might be reading assignments and stuff like that. Finally, what are the prerequisites? There are no prerequisites. We'll be covering mostly everything. You only need to be ready to learn things such as groups and groups and rings, not really rings, but only groups. And so we'll give a cursory, we'll give enough definition so that you can understand through the project. A course would be better, but still you do not need much prerequisites. Yeah, so that's it. I think the weekly commitment would be, as I stated, 2 to 20 hours. So the 20 hours will be like the peak that might ever reach, and 2 hours will be like, let's say there is you have your NCM examination, and so we'll not give much more during that time. Yeah, so that is how the project is going to be. Yeah, thank you. So if you have any doubts, you can ask me.
Yeah, so if there are no doubts, then we have come to the end of the session. And
yeah, so there's a wide variety of projects this year. I hope you can all find something that interests you, and we will float the form by tonight. You will have to indicate your preferences for the projects, and yeah, we will finish allotting them by next week. And yeah, you will get a few days to fill the form, so don't worry about that. We will also be sharing this recording. We'll be uploading it to YouTube as soon as possible. If there is any mentor-specific question, if the mentors are still present, you can ask them now. Otherwise, you can also ask them on the Ask Mentors channel on our Discord server.
I just wanted to ask, how is the allotment decided? Like you said that we'll have to give some preferences, and then on what basis are those given, the projects?
Right. So that will depend on a lot of factors. That will depend on how many people apply for that project and the prerequisites of that project, and also how many mentees the mentors are willing to take on. So it will differ from project to project. There are some advanced projects for which you will have to indicate that you have the prerequisites that you need to start the project. Yeah, for other projects, you may not need things like that. So it is very project dependent.
All right, thank you.
Any other questions?
Will we be getting credits for these projects?
Yes, if you, so we will have midterm and end-term evaluations for the projects.
Yes.
If your mentors decide that you have done the project diligently and you have covered enough material,
yes,
then your names will be sent to the student's placement office, and you will get an SPO ratification for this project. If the mentors
we will get the
SPO ratification, which you need for your internships and your placements. For your
Is that like a certification kind of thing?
Yeah, it is a certification. If you want to sit for internships and placements through the student's placement office, then you need an SPO ratification for that particular project.
Okay.
Also, this is just to add, this is not just for SPO, but also other. So, for example, in your second years, if you guys are Y21s, you might apply for SIP as well. That ratification also. I mean, basically, whenever you mention anything on your resume, you need a ratification. And to get ratified, basically, you'll need an approval from the Stamatics. Like you need to be there on the ratification list, which is subject to the fact that you successfully complete the evaluation. But also, just to clarify, if you're talking about academic credits, then you're not getting academic credits from these projects.
All right. So no credits or a relation to grades or the grade point?
No,
okay.
No, not at all.
I wanted to ask that most of the projects also have like a course associated, like in the curriculum. So like what would be the advantage of taking the project beforehand and not taking the course like in the academics?
The courses are generally listed as prerequisites. For example, for some projects, you may need some knowledge of linear algebra, for which you need to have done MTH 102.
I wanted to ask, like in machine learning, like intro to machine learning, there is also a course like on that. Like, what would be the advantage of taking the project rather than the course? Or like, what is the like thing think that
Okay,
matters.
there are several advantages. One, if you, not everybody gets the course. That course, if you're talking about the CSE course, that is pretty hard to get. The second thing is you may get that course, you're a Y21, right? So you will probably not get that course for a few more semesters. And this is a good chance to learn. Also, you can try something out without the pressure of the grading, right? So if you decide that this is not something that interests you, you can always leave in between. Of course, you won't get the ratification, but it won't have any effect on your CPI. And
Also to add, the projects are in general more hands-on, while the course in general get a little bit more theoretical. So in the sense that the projects would be much will give you a much more hands-on experience in whatever domain you're taking up. So if you talk about machine learning, for instance, probably the project will give you a much more hands-on experience than the course will. Yeah.
Okay. Yeah. Thanks.
I just want to ask something. Like there are several of these projects that a lot of us find interesting at the same time, but we can only do one. So the next year when we opt for these projects, are the same projects going to be available, or can we like? Is there any way we can do another project after some time or something like that?
No, so every year the set of projects will vary sort of, because basically every year it depends on what kind of projects the mentors want to offer. So no, it might or might not, like if you're interested in a particular project, it might or might not be offered next year.
Okay,
yes,
so if you really want to do more than one course, is there any solution?
I think you can talk to the mentor of the respective project, and that mentor would be willing to share the material of the project with you. So that way you can do it at least informally. Yeah.
Okay.
Also, there are several projects. Yeah, there are several projects that are offered. Soon you will also get S&T projects and other projects. So yeah, you will have plenty of opportunities to do many kinds of projects throughout your stay at IIT. I'm sorry, somebody was asking something.
Oh, thanks.
Was somebody asking something? I think I spoke over them.
No, I think it was just Ritin's mic. But anyway, also there are a couple of, like, there's a question on the chat in which from Gitika, which says, how can we connect to mentors? So basically, I hope you're there on the Discord server. If not, please join it. So the Discord server has this channel called Ask Mentors. You can put up your questions there. Otherwise, you can just, like, the name on Discord, username of each mentor is there on the projects page on Stamatics website. So you can connect to them either on Discord or any other medium, like text them up on Facebook as well. I'm sure they'll be accessible. Yeah. Also, just a heads up, I mean, if and like all of you are planning to do projects, you'll have to necessarily join the Discord server, because that will be used as the primary communication channel. So make sure you're there on the Discord server.
Is there anything else? If you have any other questions later, you can, of course, as Abhiman, you just said, ask on the Discord server. Okay, then I think we can end the session.
Yeah, just wanted to add one more thing, Nupur, sorry to interrupt. But
yeah,
basically, we'll float the forms by tonight. However, please take your time, do your research, and then fill the form. Like, talk to mentors, ask questions if you want to. Because once you fill the form, then it will be difficult to accommodate requests for, say, changing. So please make sure you fill the form once you are fully convinced of what projects you want to fill in for. Yeah. Yeah, Nupur, you can continue.
Yeah, so I think that can be the end of the session. Thank you so much, everybody, for attending.
I have wanted to ask one thing.
Okay.
Like you mentioned that there are other projects like the SMP projects as well. So all these projects happen at the same time.
They can overlap. You will have to contact the SMP coordinators for that. I am not aware of when those projects are going to be offered. But yeah, generally, a lot of clubs and societies offer projects and they do overlap. So, yes.
Yeah, I just had one thing. I'm not sure if it was discussed earlier, but I think I missed it. But if a lot of people apply for the same project, then how is it decided who gets to get it?
That is why you have to fill in preferences. So it will be safest that you don't just fill one or two things. You should fill as many. Yeah, I think we will have around 10 preference options for you to fill. If you don't get a first preference, you will get your second or third. And yeah.
So if you fill only one preference, it is guaranteed that will get that.
No, you might not get it. That's why you should fill as many preferences as you can.
Okay, but like how are the people chosen? Like how are we given preferences for particular roles?
Yeah, as I said before, it depends heavily on what the mentors want, what you have to. That is why you should also fill your form properly. If yeah, you have to display that you have the prerequisite knowledge that the mentors want. It depends on how many how many mentees the mentors want to take in.
Okay.
So those are the major factors.
Do we have to provide a resume or something while applying for these projects?
Not a resume, but we will ask you about the prior knowledge that you have, depending on the projects that you've taken.
Okay, thanks.
So some mentors have already said that they need a particular course to be done. Otherwise, they need some knowledge of some field of mathematics. So you have to be able to display that you have.
Yes.
Okay, I think if there are no more questions, we can wrap it up. But just one more thing before we end. If any of your friends couldn't enter the meeting initially or were say missed the meeting but they're interested, we'll put up the recording of the entire meeting on our YouTube channel and we'll post the link on Discord. So we'll do this by tonight. So just spread the word and let them know that they can watch the YouTube recording. Yeah. Okay. So if there are no more questions, I think we can end it. We can end the meeting. Thanks everyone for joining. Nupur, you can end the meeting.